Hi students, this section is on exponential growth functions. So when we're working with exponential growth functions, there is a formula we need to consider when working with this. But first and foremost, what an exponential growth function is, it's a quantity that is growing exponentially if it increases by the same percent, that's key, by the same percent in each unit of time. And that's what we call exponential growth. So this chart here, I want you to write all of this down. It's very important. This exponential growth model is the formula that you need to use to figure out situations that you're going to be solving in this section. So C is the initial amount, meaning your starting amount, we call this. So we have y equals c, your starting amount, and then in the parentheses here, it's 1 plus r. 1 plus r is your growth factor, which is your growth rate, which this is where you bring in your percent. You do have to change the percent to a decimal, and that is raised to the t power. T is represented in time. Most of the time it's shown in years. Okay, so that's the formula. We're going to be working with this formula in the next few examples. So let's practice this. First example, it says you deposit $500 in an account that pays 8% annual interest compounded yearly. Compounded yearly. What is the account balance after 6 years? So we're going to use the formula y equals c, the cost, your starting rate, parentheses 1 plus your rate, which is your percent, raised to the t power, which is your time, shown in years. So C is going to be my starting price, which is $500, plus times 1 plus my rate. My rate is 8%. We have to take that 8% and move it to a decimal. So if we think of 8%, the decimal's after 8, we move the decimal 2 places to the left. So the decimal form of 8% is 0.08. So we will substitute that in for our rate. Raised to the t, the number of years, they're representing 6 years here, asking for 6 years. So now we go about solving this. You do need to use your calculator to go about solving this. So first you need to think of orders of operation when solving this. Let's take care of what's in the parentheses first. So 1 plus 0.08 is going to give me 1.08, which is raised to the 6th power. So in your calculator, plug in 1.08 raised, that caret top button on your calculator, raised to the 6th power, and then press enter to get your answer, and it's going to be a decimal. Then you take that decimal answer and you multiply it by 500, and your y value is going to give you 793.443, and then the number next to the 3 you can round up to 4. We are working with price and cost, so we need to round to the nearest penny, and so to the nearest cent. So what is the account balance after 6 years? So the account balance is going to be approximately $793.44, and that will be my answer. Again, it's key. You need to use your calculator for this to help you answer these questions. Example number 2, again, we're writing the exponential growth model, and it says a newly hatched channel catfish typically weighs about 0.3 grams. During the first 6 weeks of life, okay, so that's a lot of our time, right? That's our time. Its growth is approximately exponential, increasing by about 10% each day. So what we need to do is we need to use our formula of y equals c, parenthesis 1 plus r raised to the t power. Now, my time here, my t, my time, they're telling us that that is 6 weeks. But what we need to do here is we need to find out how many days are in 6 weeks. Well, 42 days are in 6 weeks because there's 7 days in a week. For 6 weeks, 6 times 7 gives me 42 days. So now let's take this and set this up in the equation. My starting, now here we're not actually getting a cost, but they're wanting to know like the increase of the growth rate. So they're starting at, it typically weighs about 0.3 grams, so that's my C, 0.3 times 1 plus my rate. My rate is 10%, which is 0.10 as a decimal. Raised to the time, that's going to be my weeks changed to days, that's 42 days. Now I simplify this down and solve this. I'm going to take care of what's in the parentheses first. 1 plus 1.10 is going to be 1.10. Raised to the 42nd power, and then we take that and multiply it by 0.3. When I multiply that out, I get approximately, y is approximately 16.43 grams. And that's going to be my answer. So after about 42 days, that's how much my catfish is going to weigh. Again, I would plug this in your calculator just to see how we got those numbers, and I can review this in class as well. Last example here, we are going to write the equation again and solve. It says a business has a $10,000 profit in 1990. Then the profit increases by 25% per year for the next 10 years. Write an exponential growth model that represents the situation and solve. So again, it's y equals my C, 1 plus r raised to the t power. What is my starting cost? My starting cost is $10,000. Then we multiply that by 1 plus my rate. My rate is 25%, but 25% as a decimal is 0.25. Raised to the t number of years, that's 10 years. So now we're going to add 1 plus 0.25 to get 1.25 raised to the 10th power. Multiply that by 10,000. First, you need to, on your calculator, take 1.25 raised to the 10th power, get that answer. Multiply it by the 10,000 to get y is approximately $93,132.26. And they are talking about money and cost here, so it is money with the dollar sign, and that would be my answer. So we'll go through this in class. That is it for this section.